Project Apollo is, frankly, easy to remember and easy to find information on. Everybody knows about the time humanity came together to put a set of 12 pairs of boots on the moon, even if they only really remember one or two of those pairs. Even Project Mercury is somewhat easy to know about just because it was the first of its kind, the first forays into space. I've talked about both of these programs extensively, even though I probably still have more to say about Apollo because it never ends. But today, we're going to talk about the forgotten middle child, the interim period of critical preparation for Apollo. Today, we're going to talk about Project Gemini. First, we need to cover the obvious elephant in the room. I explained this in a short already, but the thing about Gemini is, it's pronounced Gemini. Yes, its name is derived from the third constellation of the zodiac, which is generally pronounced Gemini. It's also the Latin word for twins, lending to its association with the mythological twins and two brightest stars, Castor and Pollux. However, the staff of the Manned Spaceflight Center, later called Kennedy Space Center, always pronounced it Gemini.
Gemini began counting down. Gemini 1. Gemini number 1 lifted smoothly off the pad. The second flight test of the Gemini program. Gemini 3, the Gemini launch vehicle.
Frank Borman and Jim Lovell on the status of the Gemini 7 spacecraft.
Gemini 10. Gemini 10.
Gemini.
Why? Hard to say. It could be a result of many staff members having roots in the southern United States. However, at some point, the name simply stuck, and it became a kind of shibboleth in the space community. You know how you can always tell a Russian from a Ukrainian from the way they pronounce and spell Kiev or Kiev? In the 1960s, you could always tell a spaceflight enthusiast by the way they pronounced Gemini, as there were many, many places, especially in the media, where NASA's pronunciation never caught on. In 1965, NASA's Public Affairs Office made a statement declaring the official pronunciation to be Gemini. So, since it's their program, we'll be playing by their rules. They all said Gemini, so we're going to say Gemini. I don't care how that makes you feel, it just is what it is. Something other countries call it soccer. Also worth noting, this program takes place back during the era when the words rocket and missile were pretty interchangeable. NASA's first 3 crewed launch vehicles were also ballistic missiles, so I'm also going to be using those words interchangeably. Try to keep up. For the time being, they are and mean the same thing. We've talked before about how Apollo didn't originally have the focused goal of crewed lunar landings. It was initially just a follow-up to Project Mercury, intending to feature a 3-man crew with varying purposes ranging from working on space stations to eventually landing on the moon. However, it was clear that the jump from Mercury to Apollo was a pretty big one, so in February of 1961, head of engineering at the Space Task Group Jim Chamberlain was given a new assignment: start working on a bridge program between the two. By March, he had presented 2 initial concepts for a 2-man spacecraft at a NASA retreat on Wallops Island. He called the vehicles Mercury Mark II, and by July, had scale models ready to be shown off at McDonnell Aircraft Corporation's offices in St. Louis. Much like Apollo, Gemini didn't initially have a focused goal, or even a name. It was simply an ethereal idea for something more advanced and more robust than Project Mercury. While the first program had proven the possibility of going to space, all of the follow-up programs ran wild with ideas. Bigger, better, more capable, modified for space stations, for crews of up to 6 or 7 or 8, lunar landings, traveling to Mars, making orbital recon stations, and other nefarious military services. The possibilities were pretty much endless. In particular, Chamberlain had some big plans for Gemini revolving around the moon. In late 1961, he made proposals for both circumlunar missions and for landings, stating that these adaptations could be made much easier, cheaper, and earlier than Apollo proposals. The plan for circumlunar flights involved an Earth orbit rendezvous, not too dissimilar from the early Soyuz lunar concept, using 2 launches. One would take the Gemini craft into orbit, and another would bring an upper stage launched by a Saturn 1B and ranged from the trans stage of a Titan rocket to a Centaur upper stage to an enlarged Agena. The concept was then extended to use a pair of upper stages to place the vehicle into lunar orbit, then later return it to Earth. Finally, the Gemini lunar lander concept also had several proposals, with the earliest, made by Chamberlain, being the first consideration of a lunar orbit rendezvous for a lunar mission. A Saturn C3, one of the Saturn variants that never made it to reality, would launch a Gemini spacecraft as well as a very lightweight, open cockpit 1-man lander. The intention was to provide a fast, lower-cost alternative to Apollo, albeit with some somewhat lower standards for safety and chances for success. There existed one other mission profile for a Gemini lunar landing: direct descent. Using a Saturn V, this vehicle would have consisted of 4 modules. One retrograde module that would be used to perform the initial phase of descent, then be jettisoned about 1,800 meters above the lunar surface. Again, not too dissimilar from one Soviet idea. A second descent module would finish the job, and an ascent module would then return it to Earth, where a hardened re-entry module would be used for atmospheric re-entry and landing. This was considered a last-ditch attempt at a direct descent profile that was a heavy arguing point during the early phases of Apollo, but eventually, lunar orbit rendezvous using the new Apollo vehicles was chosen instead. There was a little more potential regarding the Gemini program than what it would end up being, however, we'll discuss those later. For now, let's go back to reality and discuss what actually happened during this program's brief but intense existence. In May of 1961, President Kennedy gave the Apollo program its cohesive goal: put a man on the moon before the decade was out and return him safely to Earth.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
It became obvious almost immediately that there needed to be an interim program between Mercury and Apollo, as Mercury had existed almost only as a proof of concept. Even before a mission mode for Apollo was decided, it was clear that certain skills needed to be developed. First, long-duration spaceflight needed to be proven for at least the 8 days required to go to the moon and return to Earth. At this time, each Project Mercury flight had only lasted for a few orbits, and by 1963, the program would end with a record flight of only 34 hours. And quite frankly, nobody wants to be stuck in a Mercury capsule much longer than that. More time was needed, and one other technique clearly needed development: extravehicular activity. Project Mercury never saw an astronaut leave their capsule, and if man was going to walk on the moon, he was going to have to open the door and step outside. Of course, a weightless EVA in orbit isn't quite the same as walking on a reduced gravity surface, but it was a start, and it would allow for the development of suit technology that could withstand the rigors of space. The Navy Mark IV, while impressive and capable of briefly shielding an astronaut from the dangers of low pressure, wasn't exactly a full-on spacesuit. Thus, the two-man Mercury Mark II program was officially approved in December of 1961, now officially christened Gemini. It was officially announced in January, and by July of 1962 had another objective added when NASA officially decided upon the Lunar Orbit Rendezvous mission mode for Apollo. Instead of taking one stage spacecraft all the way to the moon and back, Apollo would utilize a command module that would function as a kind of mobile base, remaining in lunar orbit, while a separate lander module would go down to the surface, then come back up and dock with the command module, something NASA had never done before. In fact, nobody had docked anything in space before. So Gemini was given its third objective: perform rendezvous and docking in Earth orbit and maneuver the pair of spacecraft using the propulsion system of the target vehicle. Gemini was going to have to move fast. Apollo needed to reach its goal of a lunar landing by 1970, and Gemini would run concurrently, developing the skills needed to achieve this goal while the Saturn rockets and Apollo spacecraft were being developed. Gemini would need to achieve its own goals before Apollo was ready to fly crew. The time crunch was on. In 1961, the McDonnell Aircraft Corporation was selected to build the Gemini spacecraft. This makes sense given both that McDonnell built the Mercury spacecraft and that this new spacecraft was heavily based on the Mercury spacecraft. It was essentially an enlarged version of its predecessor, with an adapter module at the bottom that would detach and burn up on re-entry. Chamberlain was the chief designer of the craft, and I suppose it's worth mentioning that he was a prime example of what's known as brain drain. He had previously been the chief aerodynamicist on Canada's CF-105 Avro Aero fighter interceptor. The Aero was intended to be the Royal Canadian Air Force's primary interceptor into the 1960s and beyond, but when the program was cancelled, a lot of the brainpower behind it was extremely frustrated. A number of Canadian engineers would move on to American projects, such as Gerald Bull, who had been using artillery to test Avro aerodynamics, as well as later being the man behind the Project HARP supergun, and Jim Chamberlain, who led a team of 25 Canadian engineers to NASA's Space Task Group. This is brain drain. When the brightest minds of your country have brilliant ideas and you take away their ability to pursue those ideas, they leave. They jump the border and work for a country that will foster their brilliance. A shameful fate for my country, but it is what it is. Mercury astronaut Gus Grissom, the second American in space, was also heavily involved in the development of the Gemini spacecraft, so much so that it ended up being specifically made for his 5'6" body and dubbed the Gusmobile. In 1963, NASA discovered that 14 of their 16 astronauts wouldn't even fit inside, and the interior had to be redesigned. Grissom would state in a posthumous autobiography that when he realized Project Mercury was ending, he put all of his effort into the Gemini program, wanting to leave a lasting mark on the American space industry. And he would, for many reasons, though unfortunately not all of them were positive. Two aspects of Gemini's design are noteworthy. First was that it was somewhat modular. All of its internal systems were individual components that could be independently tested and replaced when necessary without removing or disturbing all of the others. The other is its escape system. Let's take a look at a Mercury and Gemini spacecraft atop their respective launch vehicles. Notice anything missing from Gemini? That's right, there's no escape tower. So, how did Gemini astronauts intend to get out of the spacecraft in the event of an emergency? Get ready for this: ejection seats. Now, the big question: would they have worked? Chamberlain seemed to think so. He wasn't a fan of Mercury's escape tower, wanting something smaller, simpler, and with reduced weight. After reviewing some failures of the Atlas and Titan II ICBMs, he did some calculations estimating that the fireball from an exploding Titan II, the Gemini launch vehicle, would be much smaller than that of an Atlas, meaning the spacecraft could get away with the use of ejection seats. Maxime Fazet, designer of the Mercury spacecraft, wasn't as optimistic. Outside of concerns for injury during an ejection, he realized that they would only be effective for about T+40 seconds. After that point, the vehicle is supersonic and the seats just aren't very effective. Furthermore, he was concerned about crew members being launched straight through the Titan's exhaust plume. At the end of the day, he would remark that, quote, "The best thing about Gemini is that they never had to make an escape." Thomas Stafford in 1997 would remark about a potential abort scenario having the danger of the cabin being a pure oxygen atmosphere prior to launch, relating it to the 1967 Apollo 1 fire. Quote, "It turns out what we would have seen had we had to do that would have been 2 Roman candles going out because we were 15 or 16 psi pure oxygen soaking in that for an hour and a half. You remember the tragic fire we had at the Cape? Jesus, with that fire going off in that, it would have burned the suits. Everything was soaked in oxygen. So thank God." How do I feel about it personally? Well, John W. Young, a veteran of Gemini, Apollo, and the shuttle program, was once asked about the viability of ejection seats on the first 4 flights of the shuttle program. To quote him,
"You just pulled a little handle."
In addition to hardware changes, there were also control changes. Because Gemini had the goal of rendezvous and docking, extra capability was added. Unlike Mercury, the crew now had access to an in-flight radar and an artificial horizon, much like with a standard plane. While they had the same joystick for orientation, pitch, yaw, and roll, that Mercury had, they now also had a pair of T-shaped handles that would control translation: forward, backward, up, down, and side to side. Gemini was also the first spacecraft to have an onboard computer, the Gemini Guidance Computer, to manage and control mission maneuvers. Its core memory could retain 4,096 pieces of information stored as 39-bit words composed of 3 13-bit syllables. One of the more fascinating aspects of Gemini was the original landing plan. Rather than splashing down in the ocean, the idea was to have it land on solid ground using an inflatable flexible wing known as a Rogallo wing. The crew would be seated upright, controlling the forward motion of what had essentially become a paraglider. The wing was attached at 2 points, one near the nose and one near the heat shield for balance, and covered by a strip of metal that would be removed during deployment. They even got far enough to test this concept. There is exactly 1 photo of a test in progress at Edwards Air Force Base in August of 1964, but the design was ultimately dropped. It was a real developmental struggle to get the wing to deploy with stability, and its reliability was a concern. If it ever failed to deploy, the astronauts would be in serious trouble. Furthermore, the Gemini program was under severe time constraints, and the parachute splashdown method was already tried and true with Project Mercury. They did, however, make improvements. The capsule would land at an angle, much like Apollo would later, aside of the heat shield taking most of the impact and negating the need for the landing bag cushion that Mercury had. It was also designed to tip over onto its side, where recovery workers would attach a flotation ring around it to allow for a stable working surface during egress. Now, what would Gemini be launching on? Well, as mentioned, the Gemini launch vehicle was the Titan II, a modified ICBM. Unlike Mercury, it used only this one rocket, so let's take a moment and talk about it. The Titan II was obviously adapted from the Titan I, the first American multi-stage ICBM, which was the only one in the Titan family to use cryogenic fuels, RP-1 and liquid oxygen. Seeing the same problem that the Soviets had with the R-7, the Titan II would move away from cryogenics. The need to store your fuel at supercool temperatures increased preparation time to launch a missile, and nuclear ICBMs needed to be ready at a moment's notice. So Titan II would instead use a hypergolic fuel that could be stored at room temperature, Aerozine 50 and nitrogen tetroxide. This enabled it to be launched from underground silos, easily concealing its location from enemy reconnaissance. A simple and effective two-stage vehicle, the first stage utilized the LR-87 engine, a twin-motor system that was never flown as a single unit. Capable of burning Kerolox, Hydrolox, or the hydrazine mixture of Titan II, it was a fixed-thrust engine and capable of being throttled mid-flight or restarted a second time. Its second stage, utilizing an LR-91 engine, would ignite just before the first stage finished burning, a process known as hot staging. Currently used on the SpaceX Starship as well as a few others, this is usually done to stop a loss of thrust during the staging process. However, with Titan II, it had the added benefit of serving as an ullage system. When a first stage cuts off, this usually leaves the fuel in the second stage floating around in the tank. When the second stage fires, it can end up being starved of fuel. In order to stop this, many rockets utilize small ullage motors that use independent fuel and fire first, pushing the fuel toward the rear of the engine and preventing starvation. However, since the Titan's second stage was ignited while the first was still firing, it was never in that microgravity state and never needed ullage motors. As a bonus side effect, the second stage ignition would absolutely obliterate the top of the first stage, which just looks awesome. The Titan II GLV, or Gemini launch vehicle, made several changes to accommodate launching living beings. First, a malfunction detection system allowed ground crews and astronauts to be aware of the status of the rocket during ascent, improving response in the case of an emergency. Redundant systems were installed to lower the risk of failure, a backup guidance system, reduced thrust in the first stage to lower G-forces, and more. However, the biggest problem in human rating the Titan II GLV was an old friend we've discussed on this channel many times before: pogo oscillation. If you don't know by now, the very short version of explaining pogo is combustion instability. Fuel flow and back pressure problems cause the cycle of combustion to become variable, increasing and decreasing in such a way that the launch vehicle literally bounces along its longitudinal axis like a pogo stick. This instability can damage the vehicle, harm the astronauts, and much more. A prime example is Apollo 6, when the second Saturn V to ever fly almost shook itself to pieces. The Titan II also experienced pogo oscillation, and it took a hot minute to resolve it. Initially, the Air Force wasn't overly interested in helping. Pogo doesn't really have much of an effect on an ICBM payload, so they weren't eager to offer solutions, despite the manufacturer, Martin Marietta, suggesting fixes would be quite simple. However, the Air Force suddenly became very interested when the Manned Orbiting Laboratory was proposed in 1962. Another extension of the Gemini program, MOL was to be a crewed orbiting recon station that would utilize a Gemini capsule attached to a cylindrical laboratory module derived from a Titan II upper stage. The Gemini heat shield would have a hinge, allowing it to open up so that the crew could access the lab. The project went pretty far enough that Vandenberg Space Launch Complex 6 in California was developed to allow for polar launches, and the MOL even saw an uncrewed test launch aboard a Titan IIIC in 1966. However, MOL was eventually cancelled when it was realized that spy satellites were pretty much just as effective as a crewed space station, though it did give the Air Force the initiative to fix the Titan launch vehicle. Oxidizer standpipes were added, the pressure in the fuel tanks was increased, and a mechanical accumulator on the fuel suction side was added. With the launch vehicle now ready for crew, the Gemini program could finally get underway. But precisely who would those crews be? By this point, 4 of the Mercury 7 remained available. Deke Slayton, who was now in charge of crew assignment, had never flown in Mercury due to a medical condition, and still wasn't available for Gemini, though he was healthy enough by 1975 to fly in the Apollo-Soyuz test program. John Glenn retired from NASA in 1964, and Scott Carpenter, who had been blamed by NASA management for his problematic Mercury flight, was on leave with the Navy. That left Wally Schirra, Alan Shepard, Gordon Cooper, and Gus Grissom. Slayton gave priority to the Mercury astronauts for command of Gemini missions, and Astronaut Group 2, consisting of 14 new faces, had all been hired on to accommodate the Apollo program. Now, of course, some of them would also be flying in Gemini, as would some of the 9 selected for Astronaut Group 3. The 2 new groups were hired by Slayton after he observed the attrition rate of the original 7, with himself and 2 others being unavailable before the program had even ended. In the end, 16 individual astronauts in 10 crews would fly in Gemini, and we'll cover each of those as we cover their flights. Be prepared for some familiar faces. Taking place prior to the days of the NASA Vehicle Assembly Building, Gemini had a unique way of preparing vehicles for launch. Unlike the Mercury service platform, which was rolled back prior to launch, Titan missiles were instead rolled on tracks to an erector that would lay horizontal, entering through a hole in what would become the top once it was upright into a weight room. Once inside, the vehicle will be brought vertical with the erector, which would also serve as a work platform while it was being prepared for launch. The Gemini spacecraft, or other payload, would then arrive and be hoisted from the ground up into the weight room and integrated to the top of the rocket. Then, only once the launch countdown was active would the erector be lowered, typically somewhere between 90 and 60 minutes before liftoff. The Gemini launch vehicle, which I'll be referring to as the GLV going forward for the sake of my own sanity, was tested twice prior to a crewed Gemini flight. Of course, Titan II had already seen many flights prior to this, as an ICBM, and now was the time to test the modifications that had been made to make it a space rocket capable of carrying crew. Gemini 1, originally scheduled for December of 1963, wouldn't be ready for launch until March of 1964. The spacecraft was purpose-built for this uncrewed test, which was meant to qualify the GLV, not the spacecraft. As a result, many internal systems were replaced with ballasts to approximate the weight and balance of the finished craft. Instead of having seats, it had two instrument panels that would relay telemetry of the pressure, vibrations, temperature, and structural loads during the flight. The craft was fitted with a heat shield, but to ensure it wouldn't survive re-entry, 4 large holes were drilled through it. However, the Titan was still known at this time for its pogo problem, and consideration was briefly given to fly at least the first few missions with a Saturn I. The Air Force didn't implement their proposed fixes until November of 1963, when they flew a test missile with the improvements made to it. Finally, after further management problems were solved by unifying 2 separate teams into a single Gemini Launch Vehicle Coordination Committee, Gemini 1 was ready for launch in early April 1964. Liftoff occurred after a flawless countdown at 11 a.m. Eastern Standard Time on April 8, 1964. At staging, an anomaly was detected that would turn out to be a staple of the rest of the program, a 3-second loss of signal. It was discovered that when the second stage ignited, it created charged particles that caused a communications blackout similar to what happens to a spacecraft during entry into the atmosphere. However, despite this, the vehicle successfully achieved orbit 5.5 minutes into launch, making the mission a formal success. It didn't have much of a goal outside of reaching orbit without destroying itself or the spacecraft, and the onboard batteries weren't intended to last longer than one orbit. The second stage and the Gemini craft remained attached to one another, and the Manned Spacecraft Center tracked the two until their 64th orbit, being destroyed over the South Atlantic Ocean on April 12th. The Titan II was ready to launch human beings. Now it was time to make the Gemini spacecraft ready to do the same. Unlike the first flight, Gemini 2 would be suborbital. Much of the spacecraft systems have been checked and verified during Gemini 1, and the primary goal was to test the thing that the first test didn't, the heat shield. At the same time, there was much practice for the future that could be done from the pad using the Titan II GLV and the spacecraft being used. First, a wet mock simulated launch was conducted in November of 1964, something we now call a wet dress rehearsal. Basically, everything is prepared for launch, the vehicle is filled with fuel, and everything up to counting down to 0 and saying the big L word is done, except the rocket stays on the pad. Another important test was ingress and egress. The program now had a rocket and spacecraft that could hold crew, so it was a good chance to practice the procedures of boarding and getting ready for flight. The prime crew of Gemini 3, John Young and Gus Grissom, donned their new G4C spacesuits and headed to the pad, accompanied by their backup crew in plain clothes, Wally Schirra and Tom Stafford. This helped establish procedures for when and where donning their suits and biomedical instruments would be done on subsequent flights. Gemini 2 was delayed initially through August and September of 1964 when 2 hurricanes came to Florida. For the first, Hurricane Cleo, the second stage and spacecraft were taken down and stored in a hangar. Then when Hurricane Dora passed through, the entire vehicle was removed and then re-erected for the final time on September 12th. Following the wet dress rehearsal and ingress training, Gemini 2 was ready for launch on December 9th, 1964. The countdown proceeded completely normally, and at 0, the engines ignited and then promptly shut back down. The Gemini malfunction detection system had found a lack of hydraulic pressure and forced an emergency shutdown. Investigations revealed a cracked valve, which was repaired and delayed the launch to January 19, 1965, when Gemini 2 finally lifted off successfully. Launch was nominal, placing the vehicle into a ballistic trajectory with a maximum altitude of 171 kilometers and separating it from its upper stage. Then, back at mission control, the power went out. Gemini 2's mission was only going to last for 18 minutes, so there wasn't much point in getting things back up and running at the Manned Spacecraft Center. Instead, control of the mission was transferred to a nearby tracking ship, while the route of the power outage was traced back to television coverage. The electrical system had been overloaded by the network television equipment that was being used to cover the mission. Despite the difficulties, Gemini 2 was a nearly full success, with the only failures being that of the fuel cells prior to launch, which were then turned off, and the cooling system providing slightly higher than expected temperatures. The important aspects, the retro rockets and the heat shield, functioned perfectly well, which was what was needed to begin crewed flights. It is worth noting that, after its use in Gemini 2, the SC-2 spacecraft would later be reused, flying in a suborbital test flight for the Manned Orbiting Laboratory, making a very early case of spacecraft reuse. It was slightly modified, including being given the hatched heat shield for access into the lab. It is currently on display at Air Force Space and Missile Museum. I've said before that I have issues with the idea that the Soviet Union held all first space achievements. In fact, my main argument against that remains my most viewed video. I want to expose the USSR's perceived space superiority for what it truly was. And what was it? In my opinion, it was a tenuous grasp on a series of complicated parlor tricks that, while undeniably impressive, were often rushed, dangerous, and underdeveloped. But I'm going to say here that Project Gemini is the point where the Reds actually started to lose the space race. They fired out of the gate with their first crewed flights and satellites, but began to fumble around the start of Gemini. Early Vostok flights weren't able to achieve rendezvous, Voskhod didn't really have a goal outside of gaining a couple more firsts and was cancelled after 2 missions, and Soyuz was an extremely messy program in its early days. Gemini, meanwhile, surged ahead and started making a lot of American firsts, and this would begin with Gemini 3. Astronaut Gus Grissom had a real sense of humor about him. He first flew Liberty Bell 7, the second crewed flight of Project Mercury, and his mission was rife with problems. The primary one was that a new experimental explosive hatch blew off while he was still sitting in the floating capsule, causing it to flood and causing him to nearly drown when the recovery helicopters weren't quite ready for him yet. Hoping to avoid the same fate on Gemini 3, he named the spacecraft Molly Brown after the Titanic passenger who would go down in history as the unsinkable Molly Brown. NASA management was not a fan and asked him to change it. Grissom said, "How about the Titanic?" At this point, management relented and allowed him to keep the name Molly Brown, but this would be the last time astronauts were allowed to name a spacecraft until Apollo 9. Much like soldiers at war, astronauts have a sense of humor that can seem somewhat grim from an outside perspective, but when you're tasked with strapping yourself to a literal missile designed to carry nuclear weapons into space, gallows humor can really help. By the way, I could spend some time discussing the G4C and G5C spacesuits used for the Gemini program, but I would be repeating myself. Instead, if you're interested, watch this video in the top right corner. Now, on to the mission.
3, 2, 1, 0. Engine start. 2, 3. Liftoff. 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 142400. 142400. Liftoff.
Gemini 3 lifted off from LC-19 on March 23, 1965, marking the first time 2 American astronauts entered space together. During their 4-hour mission, they had one primary goal: change their orbit using the onboard thrusters of the Gemini spacecraft. Early on, they began to notice that the craft was drifting in attitude, continuously yawing to the left. Originally believed to be a stuck thruster, it turned out to be a venting water boiler. However, the crew were able to achieve all objectives, beginning at the end of the first orbit when a 1-minute 14-second burn changed their velocity by 15.5 meters per second and their apogee by around 55 kilometers. This would mark the first time a crewed spacecraft had altered its orbit intentionally, a major step in maintaining control in space. They would then make more burns to change their orbital inclination by 0.02 degrees, and then a final retrograde burn that lowered their perigee into the atmosphere. This way, if the retro rockets were to fail, the spacecraft would still re-enter the atmosphere. Early into the mission, one of my favorite pieces of space history ever would occur, thanks to my favorite astronaut, John Wyatt Young. Young reached into a pocket of his spacesuit and very casually held out a corned beef sandwich, offering it to Grissom. Grissom, thoroughly amused, took it, and both crew members took a few bites before it was wrapped back up and returned to its pocket. The two had quickly discovered that every bite produced an incredible amount of crumbs that they were worried would find their way into the ship's electronics, leading to warnings from management to not repeat such a stunt again. Grissom would later say that, quote, "After the flight, our superiors at NASA let us know in no uncertain terms that non-man-rated corned beef sandwiches were out for future space missions. But John's deadpan offer of this strictly non-regulation goodie remains one of the highlights of our flight for me." It's worth noting that in his biography, Deke Slayton would state that he actually gave Young permission to bring the sandwich. Lastly, I greatly appreciate this page on the NASA website covering the sandwich incident, in which it is explicitly stated that, quote, "It is unknown if the contraband corned beef sandwich was already in one of his spacesuit pockets at the time this photo was taken." Despite the overall success, two small failures did occur during Gemini 3. One involved an experiment with sea urchin eggs in weightlessness, though the only information I can find is that it was due to the mechanical failure of a lever. The other involved photographic coverage, which was considered only partially successful due to an improper lens setting on a 16mm camera. Moreover, atmospheric re-entry did not go according to plan. While initially matching simulations, the craft quickly went off course, and Grissom's ability to control the craft wasn't as effective as it was hoped. Furthermore, when the parachute was deployed, the craft abruptly swung from a vertical to a horizontal position, and the sudden movement sent Grissom forward in his seat, where he cracked the acrylic faceplate of his helmet on the control panel. However, he was alright, and in the end Molly Brown splashed down 84 kilometers short of its intended destination, where it was picked up 30 minutes later by recovery forces. Already, Gemini had achieved two goals: multi-crew flight and changing the orbit with the spacecraft. Now, two new goals needed to be achieved with Gemini 4, multi-day flights and spacewalks. Going to the moon was going to take time, requiring astronauts to remain on board a spacecraft for several days, so Gemini 4 was to be a 4-day, 66-orbit flight. Furthermore, the spacewalk objective was moved up from a later flight, as the first spacewalk in history had already been performed. Alexei Leonov aboard the Soviet Voskhod 2 had spent 12 minutes becoming the first human being to be in the vacuum of space with only a spacesuit to protect him, on March 12, 1965. To demonstrate that the USA was gaining on the Soviet lead, Gemini 4 would perform its own spacewalk, this time lasting 36 minutes, just 16 days after the Soviets. Keeping the program ambitious, Gemini 4 would also attempt to perform a rendezvous with its Titan upper stage, but this didn't end up being successful.
5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Gemini 4 launched on June 3rd, carrying James McDivitt and Ed White into orbit, with the first launch to be controlled from the new mission control at Houston's Manned Spacecraft Center, and more successful television broadcasts would bring the mission to the eyes and ears of an international audience via the use of the new Early Bird satellite. 1,100 print and broadcast journalists were on site for the launch, requiring NASA to lease whole nearby buildings to accommodate them. On the first orbit, McDivitt made his attempt to move toward the Titan upper stage, but it didn't quite work. The reason for this is a little difficult to explain. In short, orbital mechanics are not intuitive, and NASA engineers hadn't quite gotten it all figured out yet. In orbit, simply accelerating toward an object, which is what McDivitt did, actually changes the orbital altitude and velocity relative to the target. Allow me to use Kerbal Space Program to demonstrate. Here we have Spacecraft A, which I'm controlling, and Spacecraft B, which I want to move toward. If I face B and accelerate toward it, we can see my perigee drop, which will actually move me away from it as I speed up toward the perigee. To get close, I need to actually raise my orbit, which will slow me down and allow B to catch up to me, because higher orbits move slower than lower orbits. These are the intricacies and backwards logic that NASA hadn't quite worked out yet, so McDivitt was struggling to find out precisely why he was moving down and away from the target. At the same time, the upper stage was venting residual propellant, the force of which was also changing its orbit. Lacking a targeting radar, McDivitt was eyeballing it, and all of these factors combined with poor lighting conditions was making it too difficult to correctly move toward the booster. With half of the thruster fuel gone, McDivitt called it off, focusing instead on the more important spacewalk goal. The two astronauts were getting tired and a little stressed at this point, so they decided to wait an extra orbit before attempting the EVA. As there was no airlock on the Gemini craft, both men had to be fully suited up while they depressurized the cabin and performed the final EVA checklist. Over Hawaii, everything was ready, and Ed White pulled the handle on the hatch. However, the hatch didn't open. McDivitt, recognizing the problem from an earlier vacuum test on the ground, helped him get it open by jostling a spring that had failed to compress. Finally, the hatch was open, and McDivitt was confident he could close it again, so White stepped outside. Tied to a tether, he could only move so far, aided by the use of a zip gun of compressed air called the Handheld Maneuvering Unit. Reviews of this device were mixed. White stated he found it easy and effective, but heavy on fuel consumption. Others would later say that translation became difficult due to needing to calculate where the user's center of mass was, making attempts to move in straight lines often difficult and resulting in tumbling instead. Think of Wall-E with the fire extinguisher. After moving out about 15 feet from the vehicle, White began to maneuver around it, testing his ability to control himself before running out of fuel, while McDivitt took photographs. The photos are great, by the way. Have a look. Oh wait, sorry, that's the wrong one. Oh wait, no, that's one with the artist's signature on it. Oh wait, no, that one's a transparent one for use in your own images. Here we go. But for real, the Gemini 4 EVA photos are some of my favorite photos in the history of spaceflight. Just a man in his tether, alone in space. Unbothered, moisturized, in his lane, focused, flourishing. While Alexei Leonov had a host of problems on his first spacewalk, a few of them being potentially deadly, White had his own, primarily being communication. Gemini used a brand new Vox communication system, a voice-operated switch, basically a system that would turn on when it detected the sound of a user's voice. However, something was wrong with the Vox circuit. When it was on, he wasn't able to hear Capcom, having to have all of the messages relayed through McDivitt. However, at some point, McDivitt also switched to Vox because he stopped responding to Capcom as well. Over a period of 13 minutes, Gus Grissom, who was acting as Capcom for this mission, tried to communicate with them 40 times but received no response. Mission Control began to grow frustrated as they were up against a clock dictated by two factors. First, the spacecraft was going to lose line of sight with the Bermuda tracking station and be out of contact until it reached the next one. Second, the solar terminator was approaching. The crew was about to enter orbital night, and they wanted White back inside while he could still see things around him. At some point, McDivitt went off Vox, asking Grissom if they, quote, had any message for us. Grissom promptly replied with, "Gemini 4, get back in." The message was relayed to White, who, enjoying himself, tried to use the excuse of taking photos to stay a little longer. When he was finally coaxed back in, he remarked that it was, quote, the saddest moment of my life. About 20 minutes of fumbling around later, McDivitt got the sticky latch to close once again, and the craft was repressurized. A later objective had been to open the hatch again in order to throw away White's EVA equipment, but due to the latch problems, the crew elected not to do this. For the remainder of the mission, they powered down the maneuvering system and performed a handful of small experiments using sextants, cameras, and a bungee cord to practice exercise. They found themselves having trouble sleeping, partly due to constant radio contact with the Earth, and partly due to the cramped quarters. Finally, however, their time had elapsed, and they were prepared to head home. In 1965, IBM Computers was running an advertisement campaign that boasted about how reliable their computers were. So reliable, even NASA uses them. Unfortunately, on the 48th revolution of Gemini 4, McDivitt tried to update the IBM guidance computer for re-entry, and it failed. Unable to fix it, they tried to turn it off, and couldn't, until it stopped working altogether. Though they would end up 80 kilometers off course due to this failure, the crew landed safe and sound and were picked up by recovery forces. For all of its issues, Gemini 4 was, overall, another complete success. After setting their own firsts, it was now time to bypass a Soviet record: flight duration. Gemini 5 would break the record of Vostok 5, which had a flight duration of just under 5 days. Its primary goal was to extend the mission time to the length it would take to fly to and return from the moon, proving that the endurance needed was possible. It would do this by, instead of relying on the chemical batteries of previous missions, finally making use of the new fuel cells, which would convert liquid oxygen and liquid hydrogen into electrical power. Gemini 5 also had a new plan for achieving a rendezvous. Rather than using the Titan upper stage, the crew, Pete Conrad and Gordon Cooper, would attempt to meet up with the Rendezvous Evaluation Pod, or REP, which would be ejected from the bottom of the service module. Yes, I know this diagram calls it a radar evaluation pod, but this NASA Space Science Data Coordinated Archive calls it a rendezvous evaluation pod, so 6 of one, half dozen of the other. I'll just call it the REP from now on. The REP was equipped with blinking indicator lights, a small antenna, a transponder, and a few other basic instruments that would allow the astronauts to attempt to come close to it, and while it was ejected shortly after they reached orbit, they never actually got the chance to rendezvous. While preparing, the crew noticed that one of the fuel cells was experiencing low pressure, though still above the required minimum. Nevertheless, Conrad shut down the fuel cells temporarily, and the REP mission was abandoned. Tests on the ground determined the cell should still operate fine, so it was switched back on and progressively tested with components that required more and more power until it was deemed operational. However, by then, the REP was simply too far away to try and rendezvous with. A new plan was derived for a rendezvous on the fly, drafted up by none other than Edwin I have a doctorate in orbital mechanics and also I walked on the freaking moon Aldrin Jr. Buzz worked out a scheme to do a kind of practice run, which he called a phantom rendezvous, with a predetermined point in space, basically pretending that a target was there and moving. This went perfectly, the crew performing 4 different maneuvers around the target area with the exact expected results. Throughout the rest of the mission, there were a handful of small failures. One of the fuel cells developed a problem with the wastewater it produced. The water it produced was supposed to be potable, but it was in fact too acidic, about 20% more than it was supposed to be. Thankfully, this wasn't a serious issue as the crew already had enough drinking water, but there was an issue with the fuel cells that would need to be evaluated in the future. In addition, one of the maneuvering thruster blocks repeatedly malfunctioned, canceling a few experiments that required use of the thrusters. Overall, though, the mission was once again a success, even though the spacecraft again landed 130 kilometers off course because a programmer forgot about sidereal days and incorrectly entered the Earth's rotation into the computer as 360 degrees per 24 hours rather than 360.98 degrees. Now, here's where the program's timeline went a little bit out of whack. On October 6th, Gemini 6 was on the pad at LC-19 with Wally Schirra and Tom Stafford on board. They were preparing for launch, and at the same time, an uncrewed Agena target vehicle was also being prepared at LC-14. The ATV went first, and the launch was nominal until right after booster separation, at which point the Agena stage exploded. Dejected and frustrated, Stafford and Schirra exited their spacecraft ready for months of delay. However, someone had a brilliant idea. Why not, said McDonnell Aircraft of St. Louis, launch Gemini 7 in December as planned, then quickly rush Gemini 6 again, and use the two together to perform their rendezvous. While initially skeptical, NASA officials eventually agreed. Why not? Gemini 7, with Frank Borman and James Lovell, remained on schedule, and plans were made to repair and re-erect Gemini 6, now called Gemini 6A, in order to launch Schirra and Stafford shortly after them. On December 4th, Gemini 7 was launched, a complete success despite some very mild oscillations during ascent. This was the only Gemini mission to feature the G5C spacesuit, modified from the G4C to allow for greater astronaut comfort during this record-breaking long-duration flight. These 14 days in space would be a grueling experience for Borman and Lovell, but we'll come back to that. For now, let's pan back down to the Earth, where Gemini 6A sits on the pad on the morning of December 12, 1965. The grueling task of preparing the pad and launch vehicle in only 9 days was successful. In fact, crews had done it in only 8 days. Countdown proceeded nominally, and then as the clock hit 0, the LR-87 engine shrieked to life and then immediately shut down again.
9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Shut down, Gemini 6. Flight clock has started. Program reset.
Schirra and Stafford sat there with eyes bulging and hearts pounding, watching the mission times clock continue to tick away as if a launch was occurring. Officially, by the book, Schirra was supposed to pull the ring between his legs and fire the ejection seats. However, he didn't. If the vehicle had risen off the pad at all and then fallen back, the result would almost certainly be a massive and deadly explosion. In fact, here's a perfect example of a different Titan rocket doing exactly that. Schirra, though, made a quick decision based on the fact that he hadn't felt the vehicle move and didn't pull the ring. In a split second, he considered the likely reaction of an on-the-pad ejection. They would be fired out of the capsule with the force of 20 Gs, be thrown a few hundred feet into the air so that the parachutes would open in time, assuming they did open, and the likelihood of survival was about the same as the likelihood of no injuries. Not very good. So instead, they waited, Schirra remarking, "We're just sitting here breathing," until the pad crew returned and got them out of the capsule. It was later discovered that an umbilical to the Titan had fallen out before it was supposed to, which triggered the shutdown. This was actually fortunate because deeper investigation revealed that upon ignition, thrust was dying in one of the engine's thrust chambers. A dust plug had been mistakenly left in one of the lines of the gas generator, and if it hadn't fallen out, the failing thrust would have also triggered a shutdown, and this could have occurred after the vehicle had started to move. There was still time. Gemini 7 still had about a week left in orbit. So, pad crews met another absurdly fast turnaround time, preparing Gemini 6A a third time within only 4 days. On December 15th, Gemini 6A finally lifted off successfully. While they originally had intended to dock with the Agena target vehicle, the two Gemini spacecraft couldn't do this, so instead, they merely performed a rendezvous. The first rendezvous of two spacecraft in history. 3 hours and 15 minutes into 6A's flight, at a distance of over 400 kilometers, the two made radio contact, and 6A executed a burn to bring them closer together. At 5 hours and 40 minutes, Schirra spotted what he believed was to be the star Sirius out in space. However, he quickly realized that he was looking at Gemini 7. After bringing them to within 130 feet of each other, Schirra began to perform fly-arounds of Gemini 7, coming within 1 foot of it several times and taking the first photographs of one spacecraft as seen by another. After getting some sleep about 30 kilometers apart for safety, the crew of Gemini 6A contacted Houston and proceeded to transmit one of the most terrifyingly low-quality and eerie-sounding messages of all time.
We got him too, 6.
If you couldn't tell, that was Jingle Bells, played on a harmonica with a handful of small bells. This is, to the knowledge of the Smithsonian, the first time musical instruments were ever played in outer space. Gemini 6A landed safely within 16 kilometers of its planned recovery site northeast of Turks and Caicos, the first recovery to be broadcast live on television, thanks to the growing industry of satellite transmission. Now let's turn back to the grueling 14-day endurance challenge that was Gemini 7. Let's quickly just keep in mind how small and cramped a Gemini crew cabin is. Here's a good reference photo. Imagine basically spending 2 weeks sitting in one of 2 seats of a compact car, except you can never get out and stretch your legs. Oh, by the way, you're wearing a suite of biomedical trackers stuck to your body with an uncomfortable spacesuit on top of them, and oh yeah, you're kind of floating in what little space you have to move in, and you have to log and report basically every movement that you make. After reaching orbit, Borman turned the craft around and kept pace with their upper stage, as had been attempted on Gemini 4. This round was more successful, flying in formation for about 15 minutes before it was decided to save remaining fuel for the later rendezvous. They closed out their first day by doing a handful of experiments and then getting some sleep, which they found to be easier due to the decision to allow them to sleep at the same time without one keeping the other awake. On the second day, the two had planned to take off their suits, becoming the first astronauts to wear normal clothing in space, but NASA management didn't like the idea, insisting that one crew member keep their suit on at all times. The astronauts didn't like that idea either, so at first, Borman kept his suit on, sweating buckets as he did so, allowing Lovell, the bigger of the two men, to get out of his. Later, the two switched places, which allowed NASA medical officers to keep an eye on the effects of being suited and unsuited in the capsule. After 148 hours, NASA management finally relented, and both crew members were allowed to shed their suits, confident that the capsule's environmental systems were working and would continue to do so. Learning lessons from Gemini 5, they managed to improve their hygiene on this flight, using an anti-dandruff shampoo to prevent skin flakes from building up in the cabin as they had previously. Removing the suits allowed them to dry out a little instead of soaking in their own sweat, and sanitation wipes further helped with this. Around this time, NASA was still experimenting in terms of space food. Mercury astronauts made do with bite-sized cubes of food, freeze-dried powders, and semi-liquids in aluminum tubes. Astronauts generally found them unappetizing, disliking needing to squeeze the tubes to eat. Freeze-dried foods were found to be difficult to rehydrate, and crumbs were a consistent problem, floating in the cabins and endangering the instruments. Gemini food had some minor improvements. The bite-sized cubes were coated in a gelatin that reduced crumbling, and the freeze-dried foods had a new container that made them much easier to reconstitute. Borman, however, would state afterwards that he hated the freeze-dried protein bites and wouldn't recommend them on future missions. One of the least enjoyable parts of the mission for them involved waste. One of the medical experiments forced them to store their body waste for post-flight analysis, which they found extremely unpleasant. The urine collection device was difficult to use and had a habit of leaking, and Borman would suggest afterwards that a tube and valve mechanism be used to vent the urine into space, which will be implemented for the Apollo command module. After the rendezvous with 6A was complete and the shorter mission had returned home, the novelty of spaceflight had worn off for Borman and Lovell. They mostly spent their last few days reading books, Mark Twain for Borman and Walter Edmonds for Lovell. Then, to make things worse, malfunctions began to occur, one after another. Some of the thrusters stopped working, then one of the fuel cells started providing only partial power. However, despite everything, they landed safely within 12 kilometers of their intended landing site. Upon recovery, they were in surprisingly good spirits, even joking about getting married after having spent so much time in space together. Gemini 8 intended to finalize the original goals of Gemini 6. This time around, the Agena target vehicle was successfully placed into orbit, and so on the same day, March 16, 1966, Gemini 8 lifted off, carrying David Scott and Neil Armstrong into a parking orbit. After 4 course corrections and just under 4 hours into the flight, the rendezvous radar acquired the ATV. A few more course corrections later, the crew spotted the vehicle at a distance of 141 kilometers, and at 102 kilometers, they gave control over to the automatic system. They waited for a distance of around 150 feet before they took manual control again, and spent 30 minutes inspecting the ATV for possible damage. Satisfied, Armstrong maneuvered in and flawlessly docked with it, the latches clicking and a green indicator light showing that they had indeed succeeded. "Flight, we are docked. Yes, it's really a smoothie," Scott said to Mission Control. The celebration, however, would not last long. There was supposed to be a lot more to this mission. Scott was supposed to perform an ambitious 2.5-hour spacewalk, retrieving an experiment from the Gemini spacecraft and from the Agena before testing a power tool on a work panel on the Gemini. They would have undocked from the Agena during the EVA, at which point Scott would move to the back of the spacecraft adapter and don a backpack that held extra propellant for his zip gun and a 75-foot extension for his tether, practicing maneuvers in tandem with the 2 undocked vehicles. However, he wouldn't get the chance to do any of this. The Agena was pre-programmed to make a 90-degree turn to the right, which it did shortly after docking occurred, and as the 2 spacecraft went out of range of ground communications, the astronauts realized that it was also rolling, taking the Gemini with it. Armstrong quickly used the Gemini's thrusters to stop the roll, but it immediately started again when he let go. Armstrong took note of the fact that the fuel on the Gemini spacecraft was dropping fast, indicating that the problem could be on board their craft rather than the ATV. The rotation rate was increasing fast, and both astronauts became concerned that this could damage one or both of the crafts, or worse, cause the Agena full of propellant to rupture or explode. Scott switched control of the Agena back to ground control, and Armstrong acted fast, stabilizing the vehicles just long enough, undocking and backing away from the Agena as fast as possible. However, Gemini kept rolling, even faster now without the added weight of the Agena. The problem hadn't been with the Agena, and Gemini 8 was now tumbling at a rate of 296 degrees per second. Armstrong shut down the thrusters entirely, switching to the attitude control thrusters on the nose of the craft intended for re-entry to stop the tumbling. After 30 minutes of struggling and confusion, the craft was stabilized, and the decision was quickly made to bring them home. Each of the turned-off thrusters was tested in turn, and it was found that one of them had stuck on, expending almost 75% of the fuel for the re-entry in the process. Mission rules now dictated that Gemini 8 had to make an emergency landing. They stayed in orbit for only one more revolution, allowing it to land in a place where it could be easily recovered. It had intended to land in the Atlantic, 3 days from now. Instead, the USS Leonard Mason was ordered to steam toward a new landing site 800 kilometers east of Okinawa. The less than ideal aspect of this was that re-entry would occur over China, where NASA weren't able to track it. However, the spacecraft came down precisely on time and on target, and the crew were recovered exhausted but alive and in good shape. The exact cause of the thruster malfunction was never determined, though an electrical short was considered the most likely cause. Flight director Chris Kraft would write in his biography years later, quote, "Engineers tore into the OAMS system when the spacecraft got home and found a short circuit that made one thruster fire continuously. We learned an important lesson. Never put electrical power to any system unless it's supposed to be on. The OAMS was rewired so that a short circuit would always give us a dead thruster, not one that kept firing until a circuit breaker was opened by an astronaut." The next flight, Gemini 9, was also rife with problems. On February 28, 1966, Elliot C. and Charles Bassett, prime crew for Gemini 9, were flying a T-38 jet trainer from Texas to the McDonnell Aircraft Plant in Missouri to inspect their spacecraft. When they arrived at Lambert Field, conditions were poor and they weren't able to get a good look at where they intended to land. C attempted a visual approach and landing, but tragically struck one of the assembly buildings of the factory, causing the aircraft to crash, which killed both of them instantly. Now the prime crew became Tom Stafford and Eugene Cernan, originally backup crew, with a new backup crew of James Lovell and Buzz Aldrin assigned. These latter two had originally been the backups for Gemini 10, and all of this shuffling around would actually play a major part in the eventual decision to have James Lovell fly Apollo 8 and Aldrin fly Apollo 11, which made him the second man on the moon. Gemini 9 had two primary goals. First, dock with the ATV as on the previous mission, though this time with less spinning involved, and perform an EVA to the rear of the spacecraft where the astronaut would strap into an Air Force-designed maneuvering unit, essentially a backpack that would allow him to make an independent flight. Neither of these objectives would end up being achieved. On May 17, 1966, Gemini 9's Agena target vehicle was launched. However, the Atlas malfunctioned and the Agena never reached orbit. Gemini 9, scheduled for later that morning, was subsequently scrubbed. This time around, there was a backup for the ATV in case it failed. Good thing too, as the Atlas Agena was clearly not quite a reliable combo just yet. It was called the Augmented Target Docking Adapter and replaced the Agena upper stage with the re-entry control section of a Gemini spacecraft. This did require some clever engineering though. The Agena was itself an upper stage and used its own propulsion to reach a stable orbit. The ATDA, however, didn't have its own propulsion, so the Atlas rocket would have to compensate. Atlas was capable of reaching orbit on its own, being a stage-and-a-half rocket that would drop most of its first stage and use a sustainer engine the rest of the way. However, to reach orbit with the extra weight of the ATDA, the sustainer engine would have to fire for 48 seconds longer than it ever had before. A double-sized lubricant oil tank was used to ensure the engine's turbopump would last that long, and the vehicle managed to reach its intended orbit safely. However, shortly afterwards, telemetry indicated that the shroud covering the docking mechanism had failed to open properly. A very bad start, and the Gemini spacecraft wasn't even off the ground yet. Gemini 9A, now renamed after the failure of the ATV, scrubbed its first launch attempt on June 1st when the ground computers failed to keep contact with the Gemini computers about 3 minutes before launch. Unfortunately, the launch window was only 40 seconds long, and it took way too long to get the computers up and talking to each other again. The second attempt, however, on June 3rd, went perfectly. It was at this point that Tom Stafford remarked that he had been strapped into a Gemini spacecraft 6 times and launched twice. The crew spotted the ATDA at a range of 93 kilometers, a little over 3 hours into the mission. At first, they hoped the telemetry was wrong. They could see the flashing lights meant to help identify it, and believed this could mean the shroud did in fact jettison. However, as they got closer and got a better look at the slowly rolling vehicle, they found that the shroud had only opened partially, but didn't jettison, hanging open in a way that Stafford remarked looked, quote, like an angry alligator out there rotating around. The crew began to work with mission control to see if the situation could be salvaged. The explosive bolts to separate the shroud did in fact fire, they observed, but the quick disconnect lanyards that unlocked the electrical connectors to the bolts had not been hooked up correctly. This wiring was now holding 2 steel restraining bands together. They considered the possibility of cutting these bands, but their taut nature and being held together on the opposite side of the shroud made their path difficult to predict. If they were cut, they could shoot outwards and slice open an astronaut's spacesuit with ease. It was actually backup pilot Buzz Aldrin who suggested the use of surgical scissors to cut the bands, and after realizing how many sharp edges the ATDA had on it, Deke Slayton was reportedly aghast at the idea. Why exactly were the quick disconnect lanyards in such a condition? Well, that's complicated. Let's summarize it with contractor infighting. Because the shroud was originally developed for the Agena target vehicle, the decision to have it installed on the ATDA was a last-minute decision. With the Air Force being in charge of the Atlas, and the decision to use only it to reach orbit, McDonnell in charge of the shroud, and Lockheed in charge of the Agena, a massive pile of miscommunication regarding installation of the shroud on the ATDA went around. NASA had hired Douglas to inspect and sign off on the shroud installation, but McDonnell wouldn't allow them on site, stating that they could do it themselves by following Lockheed's published procedures. The procedures, however, simply said, "See blueprint," which McDonnell wasn't using. At the end of the installation process, they were left with a few dangling straps, the lanyards, and didn't know what to do with them, so they simply taped them under the covers for the explosive bolts. Douglas engineers had to use a backup fairing and set it up in the same way to prove exactly what had happened to the real thing. Oops. Someone lost their job. Maybe several someones, I don't know. Left with only their secondary objective, Gemini 9A began its EVA on the 3rd day. The suit Cernan wore had been modified from the previous one, having a lower section made of woven nickel alloy to prevent burning when he fired the thrusters of the backpack he was supposed to use. When he pressurized the suit, Cernan stated that it, quote, took on a life of its own, becoming so stiff that he was barely able to move in it. Once he was outside, he struggled to stop himself from tumbling, which was worsened by the unpredictable movements of the umbilical cable. However, he eventually made it to the rear of the spacecraft, disconnected the umbilical, and began hooking up to the backpack. He struggled with the stiff suit, his heart rate climbing to 155 BPM as he tried to put on the backpack in what he described as a suit, quote, having all the flexibility of a rusty suit of armor. Without any footholds, he struggled more, and by the time he was ready, his pulse was at 180 BPM. He took a quick rest, wiping his nose on the inside of the visor to clear away fog from his breath, while Mission Control decided on what to do. Cernan himself wasn't hopeful. He could barely see, he could barely move, and once he finished, he was dreading the task of needing to remove the backpack with only one hand, since the other would need to hold onto the spacecraft. In the end, Stafford made the call to bring Cernan back inside, leaning out of the hatch to help him remove the backpack. At this point, Cernan's visor fogged up completely, and he couldn't see a thing. Even sitting down caused him pain in the stiff suit, as he had to lean down far enough to close the hatch. One positive aspect is that these difficulties helped with planning for Apollo. Not only were workloads decreased to prevent overexerting the astronauts, but the Apollo suit will be water-cooled rather than air-cooled, helping to reduce fogging inside the helmets. I'm also going to share one of the most insane things I've ever read. In a 1999 interview, Stafford spoke about the difficulties in the flight, stating that there was concern that Cernan wouldn't be able to get back inside the capsule. If this had happened, it was deemed unacceptable to cut Cernan loose, in contrast to the Soviet plan for Alexei Leonov to swallow a cyanide pill inside his visor while he floated away and died peacefully. So the plan had been to perform atmospheric re-entry with Cernan still outside and attached. Not only would this obviously have killed Cernan, but it would need an open hatch and therefore certainly kill Stafford as well. If one must die, both must apparently.
The Gemini would be in front, but this thing is going to be whipping us all around. I says, and furthermore, I've got an open hatch and all I have is this thin suit when it goes in it. Just one layer of nylon, and I've got 3,200 degree plasma coming a couple of inches right above my shoulders through that open hatch.
However, obviously, Gemini 9A landed safely with both men inside the capsule. Following this mission, thorough reviews were done of each mission plan to ensure first that they were doable and that they would directly benefit the Apollo program. The Astronaut Maneuvering Unit, the backpack Cernan was supposed to test, was an Air Force creation that would have literally no purpose during Apollo. In fact, Deke Slayton would later speculate that the entire thing existed so that astronauts would be able to, quote, get a nice look at somebody else's satellites. Gemini 10 would attempt to finally complete some of the goals of Gemini 9A, which had attempted to complete some of the goals of Gemini 8. Dock with an Agena target vehicle and perform a spacewalk to it, as well as perform a burn using the Agena's engine to change the orbit of the two docked vehicles, as well as investigate the possible dangers of radiation at higher altitudes. At the same time, the ATV from Gemini 8 was still in orbit, though its battery had died, so there was now a goal to prove that a rendezvous and docking was possible with a passive object, a possibility that could end up being faced during an emergency situation in the Apollo program. The Gemini 10 Agena target vehicle launched on July 18, 1966, and was successful. 100 minutes later, Gemini 10 followed, carrying John Young and future Apollo 11 astronaut Michael Collins into orbit. Though the launch was successful, it did have a few interesting anomalies. At liftoff, a snared umbilical line ripped free of the service tower and was carried along with the second stage. Furthermore, footage showed that after staging, the first stage oxidizer tank dome ruptured, releasing a cloud of nitrogen tetroxide into the air. However, review of Titan II ICBM launches showed this to be a fairly common phenomenon caused by second stage engine exhaust, flying debris at separation, or just overall bending of the structure. NASA decided it didn't actually have any effect on astronaut or spacecraft safety, so they never did anything about it. It is what it is. After some problems navigating with a sextant, and a burn made without realizing that the spacecraft was at a slight angle, Gemini 10 caught up with the ATV with 60% of their fuel expended due to the extra burns necessary. However, rendezvous and docking went according to plan, and the Agena made its first 80-second burn to push their apogee up to around 763 kilometers, the highest humans had ever been at that time. The crew found the burn pretty exhilarating. Astronauts are accustomed to being pushed back into their seats, but because they were docked nose to nose with the Agena, they were instead pushed forward when its engine fired. However, this would give them a better idea of what it would feel like inside an Apollo command module if the lunar module needed to fire its engine while docked, which would occur on Apollo 13. After 2 more burns with the Agena, one to bring them back down into the same orbit as Gemini 8's ATV and one to circularize, Michael Collins performed the first spacewalk. This was a stand-up EVA, meaning he stood up in the open hatch without floating free. He spent around 50 minutes taking photos of the stars, as well as of a color plate on the side of the spacecraft, intending to find out whether or not film correctly reproduced colors while in space. Turns out it sort of does. The atmosphere makes a big difference on what photographs look like. Makes everything a little bit warmer, which is part of the reason a lot of photos and videos in space tend to look a little odd. The EVA ended 6 minutes early when the astronauts noticed a small problem. Their eyes felt irritated. After getting the hatch closed and repressurizing, it was realized that the cabin had a minor leak of lithium hydroxide. This was easy enough to fix. They simply flushed the environment system to remove the excess gases, then ran the system at a higher rate to have more oxygen in the air. The next day, after undocking from the Agena, the crew kept an eye out for the Gemini 8 ATV and thought they spotted it at a distance of 5.5 kilometers. However, they must have gotten turned around at some point because they were looking at the same Agena they had just undocked from. A little while later, they spotted a faint star on the horizon, eventually confirming it to be the Gemini 8 ATV. They managed to get about 10 feet away from it, finding it stable and in good condition, and Collins became the first person to perform 2 spacewalks on a single mission. His first goal was to retrieve a micrometeorite collector, which cataloged impacts from tiny pieces of debris from the side of the spacecraft. After a little finicking, he got it, but at some point during the EVA, it floated free of the cabin and was lost again. Next, he was tasked with doing the same with the Agena, grabbing the docking cone for support. However, the cone was completely smooth and his hand kept slipping, so instead he ended up grabbing onto a bundle of nearby wires. At this point, a piece of shroud on the Agena had come loose and, worried it would snare Collins' tether, he returned to the Gemini spacecraft. There were more objectives, including testing orbital mechanics using a tether between the 2 spacecraft, and for Young to move over to Collins without Collins moving, but these were abandoned due to the low fuel remaining. The crew were asked to come home, and landed safely a mere 3 kilometers away from their recovery vessel. Gemini 11 would really ramp up the achievements, truly demonstrating that NASA was getting pretty good at this whole spaceflight thing. After launching the ATV, the Gemini spacecraft carrying Pete Conrad and Richard Gordon performed a direct ascent rendezvous with it. This means that, instead of getting into orbit and changing the parameters to play catch-up, they instead carefully timed and calculated the launch to achieve a rendezvous at the same time the initial orbit was achieved, changing nothing after the second stage cut off its engine. This went perfectly, exactly 94 minutes after the ATV was launched, as did final approach and docking. The Agena fired its engine and brought the combined vehicles to an apogee of 1,373 kilometers, the highest apogee of any Earth-orbiting mission, all the way up to 2024 when it was broken by the Polaris Dawn mission. Of course, Apollo missions went much further, but once you fly past the moon, you enter its gravity well, and a technicality means you get to say Earth orbiting when qualifying the altitude record of Gemini 11. The crew practiced undocking and docking 4 separate times, and on the 5th rendezvous, unplanned but they had the fuel available so why not, brought themselves back down to a circular orbit of around 300 kilometers. Gordon undertook the first spacewalk and fastened a 100-foot tether between the Agena's docking collar and the Gemini docking bar. Though he got the job done, for a 3rd time, spacewalks proved to be rather exhausting compared to simulations, and Gordon's 2-hour excursion was terminated after only 30 minutes. However, with the tether attached, they could proceed with one of the main experiments. The purpose of this, called the Passive Stabilization Experiment, was to try and explore how spacecraft could maintain their orientation, or their attitude, without relying too heavily on thrusters or complex reaction wheels. The hope was that, with the Gemini further away from the Earth than the Agena, gravity would act more strongly on the Agena and pull the tether taut, altering the orientation of the Gemini. However, this didn't happen. The gravity gradient simply wasn't strong enough. However, a secondary experiment was then attempted. Centrifugal gravity has been an idea since well before the dawn of spaceflight, most famously being traced back to Konstantin Tsiolkovsky, the man responsible for coming up with the rocket equation in 1903 that we still use today. The idea is simple. If a sufficiently large spacecraft were rotated or spun at the right speed, objects within it would get pushed toward the outermost point, which can then be treated as a floor, and simulate the effects of gravity. Tsiolkovsky even ran the numbers, figuring out just how big something would need to be and how quickly it would need to rotate to achieve sufficient gravity, numbers that would eventually influence concepts by Wernher von Braun in the 1950s. So, Gemini 11 was set to spin by firing its side thrusters, slowly rotating the combined craft like a pair of small planetoids dancing around each other. Did it work? Sort of. Quite a bit of spinning would have been needed to actually create Earth-like conditions, so the slow rotation only created about 0.00015 Gs. However, this was enough for the astronauts to notice things. Small objects would drift outwards. They had, effectively, proven the concept. Gemini 11 performed a small handful of other experiments, including evaluating the performance of minimum reaction power tools, orbital photography, and testing the usefulness of a low light level television system to supplement the poor ability to see in low light conditions. The mission ended after just under 3 days, with the first fully automatic re-entry and landing, the astronauts simply sitting pretty until they splashed down 4.5 kilometers from their recovery ship. The final mission, Gemini 12, had one primary goal: to prove that an astronaut could effectively perform work outside of a spacecraft. So far, Gemini spacewalks have been largely cut short and limited because astronauts simply found it too strenuous, the worst of it being Cernan's alarmingly high heart rate after putting on the astronaut maneuvering unit, so several changes were implemented with the intent to fix this. First, they improved restraints and handholds outside the spacecraft, giving astronauts more things to hold on to instead of struggling with the floating sensations of microgravity. The problem with floating in space is that you're extremely subject to Newton's third law. Every move you make creates a reaction in the opposite direction, so the handholds and restraints were intended to improve on this. Furthermore, NASA developed a new procedure for practicing before this mission, something that would become a staple for all NASA programs going forward: underwater training. The original neutral buoyancy pool was located at the McDonald School in Maryland, where Buzz Aldrin would train with a Gemini mock-up for his spacewalks on Gemini 12. Having proven the importance of testing underwater, new pools would be constructed at the Marshall Space Flight Center, eventually leading to the modern neutral buoyancy laboratory near Johnson, needed to house larger mock-ups of the International Space Station. Liftoff of the Gemini 12 ATV occurred on November 11, 1966, with Jim Lovell and Buzz Aldrin following 1 hour and 39 minutes later, all going according to plan. Sort of. During orbital insertion, the Agena engine experienced some erratic turbopump speeds for about 2.5 seconds. Engine performance didn't seem to be affected, at least according to telemetry, but a 30 psi drop in the thrust chamber told Mission Control that there was a problem. As a result, a secondary mission objective, pushing the two vehicles into a higher orbit, was cancelled since they couldn't safely determine the state of the engine. Following the end of the mission, they attempted to fire the engine, and it never started up. A stuck fuel valve was keeping it from firing, something later believed to be caused either by melted or loose debris blocking it. The erratic pump speed was likely a red herring, caused by debris knocking around and obscuring the data probe's ability to read the engine's status. Gemini 12 went incredibly smoothly outside of this failure. Rendezvous and docking was now fairly routine, and Aldrin's 2-hour EVA finally demonstrated that it truly was EVA, emphasis on the A. No more floating around and struggling to perform the most basic of tasks. Aldrin easily managed to photograph star fields, retrieve a micrometeorite detector, and do a handful of other chores, including 2 more stand-up EVAs. Re-entry and landing also went without any issue, and on November 15, 1966, at 2:21 p.m. Eastern Standard Time, the Gemini program was officially complete. Unfortunately, Gemini was most likely doomed from the start to its frantic but ultimately brief lifetime. Had it not lived in the shadow of Apollo, had spaceflight been approached with less of a competitive and speedy nature, things might have turned out differently. Might have. At the same time, the promise of Apollo was also what helped make it so successful. The nation was dedicated to making their mark against the Soviet Union, and it forced them to act fast and decisively. But let's take a moment to explore the what-ifs. McDonnell was also a prime contractor candidate for the Apollo program, but ended up losing out to North American Aviation. Instead, they pivoted to try and find further use for what they had already developed. We discussed the MOL, the Manned Orbiting Laboratory, which existed in the era of the Apollo Applications Program, an effort to extend use of the Apollo hardware beyond the lunar program. A space station was a popular topic in these days, as they could be effectively used as practice runs for long trips into the solar system, like to Mars. However, MOL would eventually lose the fight to Skylab. While MOL primarily held military and reconnaissance purposes, it was also temporary, being used for only a few weeks before being discarded and another one sent up. Skylab, on the other hand, was not only set up to continue civilian applications of space science, but would be semi-permanent, remaining in orbit for years and seeing multiple crews. However, McDonnell didn't settle there. They began to propose a series of applications for Gemini hardware that they called Advanced Gemini. Big Gemini was among the most interesting advanced proposals, and it's exactly what it sounds like. An enlarged Gemini spacecraft capable of carrying more crew, more supplies, and be used to service space stations and perform advanced missions. It would extend the Gemini service module with a pressurized rear compartment that could hold cargo and experiments and could be capable of holding up to 12 crew members. The roles it could take on would eventually be fulfilled by Apollo hardware during the Skylab and Apollo-Soyuz eras, and later by Space Shuttle hardware. Another concept was Winged Gemini, which, again, is exactly what it sounds like. Similar to the incredibly cursed Winged Apollo proposal, it involved adding small lifting surfaces to the capsule, allowing it to function like a spaceplane. Why? Because the Air Force was mad that the Dinosaur got cancelled. No, really, that's pretty much the reason. They wanted a different spaceplane with which to do orbital reconnaissance and possible satellite stealing, but it turns out one of those roles is better served by satellites and the other is better served by the space shuttle. Or at least would have been. At the end of the day, Gemini began as a simple expansion of human spaceflight capabilities, but would soon take up the mantle of preparing man to land on the moon. Once it had fulfilled that purpose, everyone was ready to move on. Apollo beckoned, and after that, the dreams of the integrated program plan that would ultimately become the stunted space shuttle program. The world moved fast, and Gemini simply wasn't able to keep up. Spaceflight crashed its way into existence, and there just wasn't any room left for NASA's forgotten, unsung hero. Until nerds like me decide it's time to tell the tale. I hope you enjoyed it.